I'll get back to answering it. So here we go. We're going to get started. So again, this is kind of a warm-up. This is something that we discussed in a previous section. So let's see here. Whoop. My pen is making dots all over the place. All right, here we go. Okay, so when it says find the slope and y-intercept of the line 3x minus 4y equals 12, we should recognize that this is in standard form, ax plus by equals c, which isn't very useful for finding the slope. We can find the y-intercept by letting x equal 0, but since we have to find the slope anyway, we can find them both by rearranging into slope-intercept form. So that's how we're going to approach the problem. To get it in slope-intercept form, all you have to do is solve for y. And the steps are pretty much always the same. Let's take a look. So to solve for y in a linear equation in standard form, the first thing you're going to do is move the term that has the x in it over to the other side. In other words, remember, an equation keeps a balance, and we can do anything we want to it as long as we do it on both sides. So subtracting 3x from both sides, we have negative 4y equals negative 3x plus 12. All right. So once you've moved the x term, the next thing you're going to want to do is to, if there's a coefficient, a number being multiplied in front of the y, you're going to divide both sides by that number. Now when you do that, it's really important to remember that when you divide a sum, you divide each part. So you're going to divide every single term by that negative 4. So that's going to give you y equals, and then you're going to have negative 3 divided by negative 4 is positive 3/4 x. And then 12 divided by negative 4 is negative 3. All right, so now we have something that matches up with slope-intercept form, which is y equals mx plus b, most people's favorite form. And so I'm just going to write our equation right underneath here so you can see how it matches up. M is 3/4, that's your slope. And B is negative 3, that's your y-intercept. I prefer to write the y-intercept as a pair of coordinates. The x value of a y-intercept is always 0, and the y value in this case is negative 3. But we're using ALEKS, and I believe in ALEKS when they ask for the y-intercept, it's okay to just put negative 3. All right, again, if you have any questions about this exercise, you can type them into the chat bar. But in the meantime, I'm going to move on. All right, so the next one says a line goes through the points 2, 3, and 5, 4. Draw a different line through the point negative 2, 7. That's parallel, is parallel to the original line. So parallel means same slope. So you kind of have two options for finding the slope of the first line, which goes through 2, 3, 5, 4. You could draw a picture of it and use rise over run to find the slope. Or, just to remind you, we do have a formula when we're given 2 points x1, y1, and x2, y2 on a line. We can plug into the formula y2 minus y1 over x2 minus x1. I'm going to work it that way. So I'm going to, now it doesn't matter which one I call my x1, y1, but I'm going to call 2, 3 my x1, y1, and 5, 4 my x2, y2, and I'm going to plug in. So I'm going to have 4 minus 3 over 5 minus 2. That's going to give me 1 over 3. So I have a slope of 1/3. So the line that I've been asked to draw, if I know a point on the line and I know the slope, I can draw it. We often draw lines by plotting the y-intercept and then using the slope to get another point, but really it doesn't have to be the y-intercept. We can use any point on the line as our starting point. So we know that the mystery line that we're supposed to draw goes through the point -2, 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, -2, 7 would be about here. Okay, and then we're going to use the slope, and we're going to think of 1/3 as being rise over run. And I'm going to think of 1/3 as +1 over +3. So we're going to go up 1 and to the right 3, which is going to put us at the pair of coordinates 1, 8. And I'm going to draw in my line. Always draw in the line. Oops. I don't know. Well, close enough. All right, so here's my line. By the way, if you have trouble finding the coordinates of the point using the graph, the coordinates of the new point, remember rise is a change in the y value and run is a change in the x. So you can always take your starting point, which in this case was -2, 7, and you can add 1 to the y and add 3 to the x, and you'd still come up with the point 1, 8. All right, so that's kind of where we left off in class, and now we're going to move on to writing equations of lines. See how we were able to graph this line given a slope and a point? Well, we're also able to write the equation of a line as long as we know the slope and a point. We're going to do this in a few different ways. All right, so the first problem that we see here is we're going to, oops. Let me make this a little bigger. You can see this was taken from Alex. The topic was writing an equation of a line given its slope and y-intercept. So when you see slope and y-intercept, most likely the slope-intercept form y equals mx plus b is going to come into play at some point. Not always, but usually. And in this case, they're wanting us to write the equation of the line in slope-intercept form, which this is, and they're telling us that the y-intercept is 8 and the slope is -3. So we're really telling us that b is 8 and m is -3. So all you have to do in that case is plug into the slope-intercept form. So the equation of the line would look like y equals -3x plus 8. And you're done. It's one of the easiest questions on the test if you know what they're looking for. You need to know your y equals mx plus b, but I find that most students, that's one of the formulas that really sticks. So most students have that in their mind. And then if they tell you b and m, then you just need to identify them and plug them in. All right, let's look at another one. Again, our goal here is being able to write the equation of a line given information about the line. So here's one where our topic in Alex says writing an equation of a line given the y-intercept and another point. So this is slightly different because in the previous problem, they gave us the y-intercept and the slope. They also are giving us the y-intercept and the other point on a graph. And I'm sorry, my graph looks a little blurry, so I'm going to just clarify. This is the y value -2, and looks like this is the y value -6. And this is the x value 8. So this pair of coordinates on the right would be 8, -6, and this would be 0, -2. All right, so see when they say they're giving us the y-intercept, that would be the 0, -2. And another point would refer to that 8, -6. And they're asking us to write the equation of the line. Well, all we need is the y-intercept and the slope in order to use y equals mx plus b. Do we have the y-intercept? Yes, we have b. That's -2. How could we find m? They're not explicitly stating what the slope is, but how could we find the slope? Does anyone have any suggestions as to how we could find the slope? There's actually more than one way we could do this. If you have a suggestion, go ahead and type it into the comment bar. I know it can be a little intimidating to type into the comment bar, but just take a guess. That is a good suggestion. Please excuse me if I pronounce your name wrong, Mahalia. That she is suggesting that we could use the formula for slope y2 minus y1 over x2 minus x1. And she's absolutely correct. Another way we could do it would be to use, since we do have the graph, to think of it as rise over run and do it that way. I'm going to do it both ways. All right, so let's say that we think of 0, -2 as our x1, y1, and 8, -6 as our x2, y2. Then plugging in, we're going to have -6 minus -2 divided by 8 minus 0. Okay, and then that is going to be, let's see, -6 plus 2 divided by 8. And that is going to be -4/8, which is -1/2. Okay, negative looks right to me because notice that this line is falling from left to right, so it should have a negative slope. And let's see if the -1/2 works out here. So we go down 1 and to the right 2, down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. Works out perfectly. All right, so the slope is -1/2. And so the equation of our line, we're going to fit into y equals the pattern y equals mx plus b. So our slope is -1/2, that's our m. And our b was -2. So the equation of this line is y equals -1/2 x minus 2. Okay, so again, if you have any questions about any part of that, just type it into the chat bar and I will be sure to answer it. Remember that these notes are going to be in your OneNote file. I'm actually writing it in my Monday class OneNote, but I will shortly after the chat copy it into the Wednesday class OneNote as well. All right. There is another equation form that we are supposed to learn in this class, which is called the point slope form. It's a form that you can use when you have a slope and instead of a y-intercept, just a random point. So the equation looks like y minus y1 equals m times x minus x1. By the way, that comes from rearranging the slope formula with, instead of an x2, y2, just a y and an x, and then multiplying both sides by the denominator. You don't need to know this, but sometimes it's helpful to know where a formula comes from to help you memorize it. In any case, let's talk about how we use it. So I've copied it down. And by the way, just to be clear, this x1, y1 is just a point on the line. So that's what these two are. And the slope m, of course, you're familiar with from the slope-intercept form of a line. All right, so let's see how we might use the point-slope form of a line. Now, I really include this example just to give you a heads up. You might see this in Alex. And it says graph the line y plus 3 equals 3 times x minus 1. Most likely, most people seeing this exercise would distribute through the parentheses, move the 3 over, and use the slope-intercept form of the line to graph it. And there's nothing wrong with that. But the intention of the authors who wrote the questions in Alex was for you to do something different, to recognize that this fits the point slope form. See how the topic is graphing a line given its equation in point slope form? So there's nothing wrong with rearranging this to graph it, but notice you don't have to. This actually fits the pattern where this would be your y minus y1 equals m times x minus x1. It's a little bit awkward to see what the value of y1 is because it's written as y plus 3 instead of y minus, but y minus negative 3 is the same as y plus 3. So what's actually being subtracted on the left, or in other words, the y coordinate that we're looking for is negative 3. The x coordinate is just a 1. x1 is a 1. So we're being told that the line goes through the point 1, negative 3, and then the slope matches up with the 3 there. So you could use the point slope form, plot the point 1, negative 3, and then use the slope of 3 to find your next point. Now if you have a slope of 3, you can either think of it as positive 3 over positive 1 or negative 3 over negative 1. Either way will lead you to another point. I'm going to use the one most people would, which is positive 3 over positive 1. So starting at 1, negative 3, which would be here, 1, negative 3, we're going to go up 3 and to the right 1. So if you go up 3 and to the right 1, we're at the point 2, 0. Now remember, it's not enough just to plot those 2 points. You actually have to draw in your line. Okay, so that is about like that. Okay. All right, so that's what they're intending for you to do when you see that problem in Alex. All right, the next type of problem that we're going to look at is where we're given a point and a slope, and we're using the point slope form of a line to find the equation of the line. Turns out that as long as you know one point and the slope, you can always write the equation of a line, just like you can always graph the equation of a line. So we're going to try actually 2 methods. One is to use the point slope form. Since we were given a point and the slope, we can think of this as x1, y1, and this is our slope m. And then we'll look at another method after that. And you can use whichever one you like better, okay? So to use the point slope form of the line, we're just going to plug into y minus y1 equals m times x minus x1. So that's going to be y minus, now y1 is actually 2, and that equals m, which is 3/4, times x minus x1, which is negative 8. Okay, so that means y minus 2 equals 3/4 times x plus 8, because minus a minus is a plus. All right, so at this point, it's pretty much always the same. You're going to distribute through the parentheses. So you have y minus 2 equals 3/4 times x plus 3/4 times 8. All right, now you can use your handy dandy TI-30X2S calculator, which I want to remind you that if you haven't got one yet, That's the only kind that you can use on the proctored tests. And remember, it has the fraction key a b over c. So you can always use fraction functions on that calculator, but thinking of the 8 as 8 over 1, when you multiply fractions, you multiply straight across, but we usually reduce before we do that. So 4 goes into 4 once, 4 goes into 8 twice. 3 times 2 is 6. So we have y minus 2 equals 3/4 x plus 6. And then the last step is to get that y completely by itself. If we're looking for slope-intercept form, you want y by itself. And in this case, they asked us for the slope-intercept form of the line. So we're going to get y by itself, and we're going to have y equals 3/4 x plus 8. And this would be your final answer. Now notice that although they asked us to write the equation in slope-intercept form, we didn't have to use slope-intercept form to get the equation. We actually used the point-slope form, and then at the end we just got y by itself to give our answer. That's going to happen a lot. You're going to be asked to give the equation of a line in either standard form or slope-intercept form, but you're going to use a different form to actually get it in get the equation written in the first place. So don't worry about what form you're giving your answer in until the end, is the moral of that story. All right, now I promised you we do a second method for the same problem, so I'm going to slide over here. So method 2, and this is actually the one I like the best, is actually using y equals mx plus b. Even though we weren't given the y-intercept, what we can do is we can say, well, this the equation of a line always fits this pattern, y equals mx plus b, where x and y represent any pair of coordinates on the graph. And so instead of thinking of negative 8, 2 as our x1 and y1, it's going to substitute for x and y. So we're going to have 2 for y equals m, which is 3/4, times x, which is negative 8, plus b. And so what we have here is an equation that we can solve for b, the y-intercept. So multiplying 3/4 times negative 8 is just like multiplying it times 8 like we did a minute ago, except it's a positive times a negative, so we're going to get a negative. So we have 2 equals negative 6 plus b. Now we're going to add 6 to both sides of the equation to get b by itself. And we're going to get that 8 is equal to b. All right, now the only downside to this method is sometimes people forget kind of what the goal is and they stop right there after they found b. But remember, we were asked to find the equation of the line. So what we need to do is plug into y equals mx plus b. We now know m was 3/4 and b was 8. So y equals 3/4 x plus 8. And you see we got the same answer that we did a minute ago. Okay, so when you're asked to find the equation of a line given the slope and a random point that's not the y-intercept, you can use either of these two options. Sorry about that, my phone was ringing. Okay, so that's how we write the equation of a line given a point and the slope. And we're going to practice a couple of these, but before we do, I need to mention one more thing. For the purpose of this lesson, I'm just going to briefly mention parallel and perpendicular lines and what that means. But there is a video on this that I have posted that you can watch. The link to it is in your OneNote under day 3.5. you can come down to this link here on day 3.5 and watch the video. And it's all about slopes of parallel and perpendicular lines. Okay. But the main thing to know about parallel and perpendicular lines, I can teach you in very, very quickly. So parallel lines have the same slope. Okay, so they run side by side without ever touching. So for example, the line y equals 3x minus 5 is parallel to the line y equals 3x plus 2 because they both have a slope of 3. Perpendicular lines meet at a right angle, at a 90-degree angle. So they look like this or this, all right? They meet at a right angle, and their slopes are opposite reciprocals. Opposite meaning if one is positive, the other one must be negative, and reciprocals meaning that if they're in the form of a fraction, if you flip it over, one is the same as the other. So like, for example, 2/3 and -3/2 are opposite reciprocals. 4 and -1/4 are opposite reciprocals because you can think of 4 as 4/1. Right, the reciprocal of a number is just 1 over that number. So if the slope is m, you can find its reciprocal 1 over m, but you need to take the opposite if you want to get perpendicular lines. So for example, if y is equal to, let's say, -2x plus 1, we know that's going to be perpendicular to what? Well, take 1 over -2 and negate it, and you're going to get positive 1/2. So it would be perpendicular to, say, 1/2 x minus 7, because their slopes are opposite reciprocals of each other. So with that in mind, sometimes when we're asked to write the equation of a line, instead of specifically stating the slope of the line, which of course we need the slope of the line to write the equation, instead they'll compare it to another line, and they might say it's parallel to the other line or perpendicular to the other line. So let's look at a couple of examples of writing equations of lines, and we're going to keep that in mind. I'm going to, for the sake of time, start with number 3 here. So the line parallel to y equals 2x minus 7 through the point 0, 1. We're supposed to give the equation of this line in standard form. Okay, so remember, when they ask you to give the equation of the line in a particular form, don't worry about this until the end of the problem. Don't worry about this until the end. Okay, what you want to focus on right now is in some way, shape, or form, they have to be giving me the slope and a point. And it would be great if they gave me the slope and a y-intercept. But at least they have to give me a slope and a point. It's just easier if they give me the slope and a y-intercept because I can use, then I'll know m and b, and it's very easy to write the equation of the line. All right, so how are they giving me slope in this case? How can we find the slope? Well, when you see the word parallel, you know that they're giving you something with the same slope. So the slope of our mystery line, right? We have a line we already know, y equals 2x minus 7, but we're trying to find some other line, the mystery line. And we want to know what's the slope. Well, we know it's the same as the line we were given. So the slope is going to be 2. And then in some way, shape, or form, they also have to give us a point that our mystery line goes through. They're telling us that that point is the point 0, 1. So we have a slope and a point, so we know we can find the equation of a line. That's all you need. Okay, but it would be nice if that point's a y-intercept. Can you tell me, is 0, 1 the y-intercept of our mystery line, and how would you know? So if you think you know the answer to that, go ahead and type into the chat bar. Is 0, 1 the y-intercept? And how do you know? I see we're having some streaming issues. Sorry about that. I'm just going to repeat the question in case your video went out. Is 0, 1 a y-intercept? So to answer that question, think about where 0, 1 would appear if you graphed it. Would 0, 1 be on the y-axis? Because that's what all a y-intercept is. It's a point that where the line crosses the y-axis. So would 0, 1 be on the y-axis? I see your question, Mahalia. Yes, you're right. It would be on the y-axis. All right, so just to recap, in case the video went out or just didn't follow, what we're trying to do is we're trying to find the equation of some mystery line. Okay, and all we know about that line is it's parallel to the line y equals 2x minus 7, and it goes through the point 0, 1. To write the equation of any line, you need the slope and a point. So in some way, shape, or form, they have to be giving you the slope and a point. They're giving you the slope by telling you that it's parallel to y equals 2x minus 7. They're giving you a point because they're giving you 0, 1. So we have a slope and a point. But the reason why I'm asking if it's a y-intercept is because if it's a y-intercept, then we can find the equation of the line very easily because we'll be able to just replace m and b and we'll be done, as opposed to having to use point slope form or solving for b. So since the x-coordinate of this point is 0, which means that this is actually a point on the y-axis, then this is actually our y-intercept. So they have given us that b is equal to 1, and we have far less work to do in that case. So our equation looks like y equals 2x plus 1. Now we're not quite done, but this is the equation of the line. It's just that it's in slope-intercept form. To get it in standard form, we want ax plus by equals c. All that really means is we want our x and y on one side and our constant on the other. So to get from slope-intercept form to standard form is very easy. Remember, this is the equal sign, has to stay balanced, so we're going to subtract 2x over to the other side, and this is going to be negative 2x plus y equals 1. Got a little crooked there. Okay, so your final answer is negative 2x plus y equals 1, writing it in standard form. But you don't worry about the standard form till the very last. All right, let's try one more problem where we're writing the equation of a line. The line perpendicular this time. We're looking for the line perpendicular to y equals 3x minus 1. through the point negative 6, 9. Okay, so we're looking for some mystery line. And in order to find the equation of that mystery line, we have to know a point and we have to know a slope. Okay, so some way, shape, or form, they have to tell us a point and a slope. The point is pretty clear, negative 6, 9. By the way, this is not a y-intercept this time because the x is not equal to 0, so this is not a y-intercept. And the slope, how are they giving us the slope? Well, they're telling us that our mystery line is perpendicular to y equals 3x minus 1. So we need the opposite reciprocal of 3, right? Because if our line is meeting that line at a 90-degree angle, its slope must be an opposite reciprocal. I'm sorry, you can't read that word very well. Let me rewrite it. Opposite reciprocal of 3. All right, so what does opposite reciprocal mean? It means you take the opposite sign and you take 1 over that number. So the slope that we're looking for is negative 1/3. Okay? All right, so now we have a point. Unfortunately, it's not the y-intercept, so we can't just say, oh, b is 9. And by the way, that is a common error that I see on the tests, so watch out for that. B is not 9. Okay, we don't know b yet. So we can either plug into y minus y1 equals m times x minus x1, the point slope form. Y minus y1 equals m times x minus x1. Or we can plug into the slope-intercept form, but with the purpose of solving for b. I'm going to do it both ways. All right, so if we use the point slope form, we just have to identify x1 and y1. X1 is going to be negative 6, y1 is going to be 9, and we already found that our slope is negative 1/3. So plugging in, we would have y minus 9 equals negative 1/3 times x minus negative 6. Make sure to include the sign there. So that would mean y minus 9 equals negative 1/3 x if we distribute through the parentheses. This is going to be a plus 6. So negative 1/3 times positive 6 is going to be minus, let's come off to the side, negative 1/3 times positive 6, 6 over 1. 3 goes into 3 once, 3 goes into 6 twice, so that's going to be negative 2. So minus 2. And then we're going to add the 9 over, and we get y equals negative 1/3 x. Adding 9 to both sides, we get plus 7. At this point, we have the equation of the line, but you want to check to see what form we're asked for. It says give the equation of the line, oh good, in slope-intercept form. So that's already in slope-intercept form. We don't have to do any rearranging. Okay, so that's one way. The other way is to plug into y equals mx plus b and solve for b. So if we did it that way, we would let y be 9. We know m is negative 1/3. X is negative 6. And we would solve for b. This is a 6, by the way, and that's a b. Okay, so remember when we multiplied negative 1/3 times positive 6, we got negative 2. It's going to be the same except positive. So 9 equals 2 plus b. Subtracting 2 from both sides, we get b equals 7. So using the slope-intercept form, we have y equals negative 1/3 x plus 7, which is the same thing we got using the other method. Okay, so in short, if you want to write the equation of a line, you need a slope and a point. But they don't always give you that information directly. They can give it to you in various forms, including telling you that your line you're looking for, your mystery line, is parallel or perpendicular to another line. Okay, we're almost done for today, but remember, if you have any questions about any part so far, feel free to post it in the comments. I'm going to move on, though, to an application. This is actually Chapter 2, Section 4 in your textbook. I'm going to make it a little bit bigger here. Okay, so we can also do applications with linear equations. It says when Joe graduated from college, he had $1,000 in his savings account. When he began working, he decided he would add $120 per month to his savings account. Number 1, write a linear equation to compute the amount of money Y in Joe's account after X months of saving. And number 2, use the equation to compute the amount of money in Joe's account after 6 months. And number 3, Joe needs $3,160 for a down payment on a car. How long will it take for Joe's account to reach this amount? Okay, so let's start with number 1. Number 1 is sort of giving us a clue because it's telling us that we can write the relationship here to represent the relationship between the months of saving and the amount of money in the account using a linear equation. All right, so remember, to write a linear equation, we need a slope and a point. So I'm going to look at this from an algebraic way where we say, how are they giving us a slope? How are they giving us a point? And then I'm also going to just show you how we can also draw the same conclusion using a pattern. All right, let's start with the pattern. I think the pattern is a little bit easier. So isn't it true that to calculate the amount in his account, after X months, that's always going to be equal to his starting amount in the account plus it's going to be, $150 times X, the number of months. But maybe that's not so clear to you, so let's just start with the first month and see if we can justify what I just said. So for the first month, how much money does he have in the account? Well, he starts with his $1,000 deposit, and then at the end of the first month, he adds another $120. Right, only 1 month, so $120. So he gets $1,120 balance at the end of the month. First month. I'm going to write that over here where it's a little closer. Okay, how about the second month? So then he'll have that original $1,000 that he started with, plus he'll have the 120 from the first month and the 120 from the second month. In other words, 120 times 2. Or 240. So he'll end up with 1,240 in the account, right? 120 more than he had at the end of the first month. At the end of the third month, he's going to have $1,000 plus. Now, this time he's added 123 times. 120 times 3 would be 360. So at the end of the third month, he has $1,360. You follow me? All right, so How about the xth month? So at the end of the xth month, he has the $1,000 that he started with, plus he has $120 for each of the x months. So the equation could be written as y equals, y being the amount in the account after x months, the starting amount, 1,000, plus, oh wait, is it 120 or 150? Oh good, 120. I wrote 150 here for some reason. Sorry about that. Plus 120 times x. Now notice that this is a linear equation. It's actually in slope-intercept form. If you just rearrange it like this would be your mx plus b. So there should have been a way that we could solve this problem using a point and the slope. So let's think about that. Let's go back to the information that we were given. Oops. My program is freaking out a little bit. Sorry, guys. Okay. All right. So let's try and recognize from the information we were given what's the slope and what's the y-intercept. All right. So if x is the number of months, then the y-intercept is when x is 0, right? At 0 months. That's the point 0, 1,000, because he's starting with $1,000 in his account when he opens it after no time has passed. And then when he began working, he decided to add $120 for each 1 month. $120 is the y value. It's increasing by 120. And the x value, the number of months, is increasing by 1. So your slope is 120 over 1, or just 120. So that, oh, sorry. So another way, that's another way you could think about this problem is the slope m is 120 and b is 1,000, and you would still get y equals 120x plus 1,000. So you can either follow the pattern or use what we've learned from algebra about the equation of a line involving slope and y-intercept. All right, now the next part of the problem, that's kind of the most challenging part of the problem, is finding the equation of the line. So now we have that. So it says use the equation in number 2 to compute the amount of money in Joe's account after 6 months. So after you find the equation, we often want to use it, and we'll either be given the x and asked to find the y, or vice versa. So in this case, are they giving us the x or the y? Well, remember, x is the number of months of saving. So this is an x value they're giving us. X is equal to 6. And what they're asking us is how much money is in the account at the end of 6 months. That's your y value. So let's come down here to work number 2. If y is equal to 120x plus 1,000 and x is 6 months, we can just plug in to find y. So y is equal to 6 times 120 is 720 plus 1,000 is equal to 1,720. So he'll have $1,720 in his account at the end of 6 months. All right, and then the last problem, Joe needs $3,160 for a down payment for a car. How long will it take for Joe's account to reach this amount? Okay, so if this is supposed to be the amount in the account, $3,160, that's a y value. So they're giving you y, and they're asking you how long, or for how many months. They're asking you to find x. So if y is 3160, let's find x. Y equals 120x plus 1,000. The y is going to be 3160, and we need to find x. So we plug in 3160 equals 120x plus 1,000, and we solve for x. So first we need to subtract 1,000 from both sides. And that gives us 2160 equals 120x. Now we need to divide both sides by 120. So 2160 clear. 2160 divided by 120 is 18. So X is equal to 18 months. Okay, so that's it for today. Remember to please go into your OneNote and watch the more detailed explanation of slopes of parallel and perpendicular lines. You can look at the notes on the page, scroll down to the bottom, and you can see the link to the video. The video for this lesson will be posted within 24 hours. The link will be in your announcement section of D2L. Thank you very much for attending. And remember, if you're in the Wednesday class, Broward College does have class tomorrow, but we are not meeting because this was our class this week. So that's so that we stay in sync with my Monday class. All right, so guys, have a great week. Remember to do your status report for day 3, please. Please do your status report.